I'm recording. So, what we've got is, I've skipped a little bit. I think you're kind of okay with what algebra is now. So, if I look at those three things, they are called equations. Okay? Like you were using with your centipedes and millipedes. The reason why I could skip a little bit is because you were all pretty good with how you wrote your stuff down, your equations. So if I ask you, put your hand up, tell me A, remember algebra is a language, it's telling me something. I'm going to ask you to tell me what it's saying without saying n plus 7 equals 10.
It's asking like what equals.
It's not asked, it is making a statement. What is the statement?
Figure out.
I'm not asking for figure. What is that statement? Without saying n plus 7 equals 10. James?
1 plus 7 equals
Kind of, yeah. I wouldn't have used the word what. I'd have just said. Yeah, overdoing it now. A number, let's call that number m, right, is increased by 7. It has 7 added onto it. After you've done that, the answer is 10. Okay? That's basically what it's saying in overflowery language. I am going to ask you to use overly complicated language rather than just saying n plus 7 is 10. Right? I'm asking you to interpret it, understand what's telling you to do. So it's telling you something, a number, we don't know what it is yet, had 7 added on, so it was increased by 7, we got the answer 10. Now, that enables me to work out what m must have been, right? Not asking you to do it yet. What does B say? Colton.
5 lots of an unknown number are equivalent to 20.
Okay, 5 lots of something has the same value as 20 equals 20. Right. I know you know the answer. I'm just asking, how do I read this? And yes, just like A, with B, if we know that 5 lots of something equals 20, then we can, using mathematics, work out what the something must have been. Okay. Someone different that hasn't had their hand up yet, looking at other people, tell me what C is. So people with your hands up now, you can put that. Right. I mean, I wasn't saying you were wrong, but so something is divided by 10, and I get the answer 4. So again, what you're trying to do already, some of you, is make other statements that are therefore true. Okay. So let's look at these. So the big thing is, I need you to understand, what does solve mean in mathematics? Okay? No, it doesn't. No, it doesn't actually.
Find the unknown number. It could be like.
Well, an answer could be an unknown number. Pardon? It doesn't actually. Solve has a very specific meaning in mathematics because there are other words like evaluate. No, they don't.
Yours might sound like you're being fancy now.
No, I'm not. So, for instance, what I can do with this one, have you written this down by the way?
Yes.
n plus 7. So I can say to you, 3 plus 7. I can give you that question and I would use the word evaluate. Evaluate 3 plus 7. And you would tell me 10. The answer is 10. The answer to evaluating 3 plus 7 is 10. However, if I said solve, I don't say solve 3 plus 10. I say solve something plus 7 equals 10. So it's like solving a problem. You have been posed a problem that is not simply just work out the answer. Okay? So something has already happened. How do people solve crimes?
Investigate. Like.
And because the crime has already happened, yeah? So this is an evaluation that has already happened, and we are trying to solve where the beginning was. So you solve a crime, do you always look at the evidence and try and work backwards?
No. Yeah.
Yeah, you do, don't you? What's the first thing? How did they, let's say it was a murder. How did they die? That's the first thing, right? They got shot. What do you then do? Well, we figured out they got shot. You?
Look for leads or
Well,
start.
what are they though? So you find the bullet and you try and match it to a gun. Then you find the gun and you try and match the gun to the person using fingerprints. Yeah? So, do we not go backwards? We do. Yeah? We look at what's happened and we try and work backwards to figure out who caused it in the first place. So when we solve, we are saying, and you might go, this is too simple, why are we doing, I know the answers. But you probably did an alternative statement, right? Which was, if n plus 7 equals 10, m must equal
10 minus 7.
10 minus the 7. So, we're working backwards, exactly. I'm trying to say, well, what must the answer have been before I added the 7? So we can then say m equals 3. Now, you did some work on function machines as well. So I would write this as, well, if I know this is m, and what happens to it is we add 7. What comes out the other end? 10. So, what do? We start with the 10 and we go backwards and we say, what is the inverse of adding 7? Minusing 7. So 10 minus 7 is 3. So m must be 3. Now that's a very simple case. Okay? So you can write this down. This is an important word. We are using an inverse operation in the reverse order. It's really important that we know what order things happened so that we can unbuild it. I like to think of it as an equation was built up and we're trying to unbuild it to get to the beginning. One thing you will always get, I mean, you might get a new teacher that says something different. I hope not, because we have learned that what we don't do, which you might see in certain things online and in some books, we don't move things from side to side. Because you might argue, oh, I've just moved the 7 over the other side. And then people go, oh, but now it's my, oh, move it and change the sign. No. Okay, what we do is we actually write this missing line in, which I would write. We say m plus 7, I'm going to minus 7 on that side, and I'm also going to minus 7 on that side. I'm going to do the same to both sides, and what happens? For the m plus 7 minus 7, I'm left with just m. And the 10 minus 7 ends up being 3. Okay, that's a really fundamental thing for me to get over to you. All right. What about the next one? So we've got evaluating would be saying 5 times, no, 5 times 4, evaluate it, it's 20. Yeah, so I would be, because we already know the answer, evaluate 5 times 4. Okay, if I said to you evaluate that, you would get the answer 20. Okay, but we're going to solve 5k equals 20. So 5 times something. So what can we do to unbuild this? Okay? That's one of the issues. We don't do 5 divided by 20, we do 20 divided by 5. So what we're going to do, if 5 times, so we started, I'll write this like this, k gets multiplied by 5, and I get the answer 20. So 20 has to be divided by 5, and I get the answer 4. Okay? So how do I write it in this way instead? So I would do the same to both sides. I would undo the times by 5 by dividing it by 5. That would give me k equals. But of course, if this side is divided by 5, so's the answer. So 20 divided by 5 is 4. Written that down? I'll pause. I'm going to show you how I could adjust this question to make you show me the answer. Right? We've got P is divided by 10 to equal 4. So let me show you this. I'm going to give you a question that says P divided by 10 equals 4. Show that P equals 40. Okay? What did I do with a question like this that messes people up? Dalton.
You gave them the answer that they thought they were going to be finding, or people might think that they're going to find. And it said, well, now you have to show you're working out to find the answer that's already given.
Exactly. So I can change a question completely. You still have to work out that P is 40. You just know that's the correct answer. But if you were intending just to write down P is 40, no marks, because I've already told you that. Yeah? So this is how I could say. Okay. Did you have a go at doing it? Okay, so I'm going to go P is divided by 10, and the answer is 4. So that means the number must be bigger than 4, right? How do we work it out? Well, obviously we do 4, and we must have 10 lots of that, haven't we? So we times it by 10 to find out that the answer is 40. So that's using function machines, but I can equally do this. I'm going to show my working algebraically by just saying, well, that times 10 on both sides, and that gives me P, because that cancels with that, equals 40. Okay.
Are they both equal amount of points, or is that the way you've been?
What I would suggest is at the moment I'm happy for you to use this method, but you'll get to a stage where this is what you want to do. This will just take too much time. Yeah, you can do that. I'm absolutely fine with that as long as. Here's one thing: I did see someone misuse the equals sign. You lied. Did you understand why you lied? So, just hopefully you've all written that down, but let me just say, what did we write? So, if we say 4 times 10, this is for the test by the way, so it's separate. 4 times 10 equals 40, minus 4 equals 36. that was the number of legs for 10 body segments. Is that all right?
No.
Is that the correct answer?
Yes, I
Yeah, that's the correct answer. Is my communication atrocious?
Yes.
Because we've said 4 times 10 equals 36. 4 times 10 equals basically means 4 times 10 equals 36.
But
down, once you take away.
You have to do it as 4 times 10 equals 40. 40 minus 4 equals 36. It's separate calculations. Be very careful. And I say that because people do this when we work these out. They put multiple equal signs along the same line. I will mark you. Okay. How do you feel about it?
Good.
2 layer ones. I'll let you have a go. Just finish this off then. What does that say to me? Anna? Just read it. So I've got a number. What do I do to it? What would I do? So I'm just asked you to read it to me without doing it. So what does that say then? I think of a number and think of a number and do what?
times it by 5.
So the number gets times by 5 first, then add 13, then you get the answer 28. So we start with 28 and we have to subtract the 13 to figure out what it was before we added the 13. But that is 15. Yeah? We then take 15 and we divide that by 5 and we get the answer 3. Okay? So if I was to write that in a different way, 5x plus 13 equals 28, I would subtract the 13 first, because I know that that was the thing that was done last, is where we've got to talk more. So then it becomes 5x must have equals 15. We then divide both sides by 5 to find out that x equals 3. So, okay. Your homework is based on lots of this sort of stuff,
Yeah.
but we'll do more of it next time. Hopefully you note that down before you get up and leave. Otherwise, have a lovely day, put your chairs up and walk there.